Mixture problem. And a lot of people hate that. But actually, if you take a deep breath and you dive in, you'll find that it's not that bad. It's not that hard. You just set up a linear equation. So, problem 8. Problem 8, in chemistry class, 4 liters of 4% silver iodide solution must be mixed with 10% solution to get a 6% solution. So, now this sentence, what does it mean to you? What do you mean by 4% of the solution? What is the 4? What is 100? 4% means part over whole, right? What is the whole? What is the part? Huh? Yeah. Well, that's the number. But what is the 4? What is the 100? What is part? What is the whole? Here.
The 4 is the part. The 100 is the whole. The 100 makes up the 4 liters, so you're dividing with.
The 100 is what? The 100 is a solution. The whole is a solution. What is the part?
Silver iodide.
Silver iodide. Okay. Okay, when you're talking about mixtures, you always want to find out this is our part. And whole is the solution. The whole thing is the solution. That is our whole. Okay, 4%, when we took a percentage, is always part over whole. Right? So in this case, we have how much? We have the silver iodide over the whole solution is 4 over 100. That's what it means, 4%. Okay? Now, they want us to figure out by adding a 10% solution to get 6% solution. So we start with this. This is our starting point. And we end up with, let's say, 3. So we're going to do 2, step 2. At the end of it, what we got?
6%.
6%, which is what? Same thing, right? The silver, upright like that. Over the solution, it's going to be 6 over 100, right? Okay? So now, we need to figure out this solution and this solution is going to be different now. At the beginning, we only have how much? What's the solution? At the very beginning, what's the volume solution?
4 liters.
4 liters. Okay. Now, how much is our silver iodide? Huh? 4% times what?
4.
4. So we end up with what? 0.16, right? That's how we started. We got 0.16 silver iodide. This is 4 liter. And also notice when we do the proportion, we are comparing the same thing. So right now we are talking about the volume. What's the volume? Silver iodide versus the whole volume of the solution. So silver iodide is part of the whole solution, right? You good on that one? So then we're going to add something to get here. What's adding? How much we're going to add? That is what?
10%.
It means the solution. How much is solution we're going to add to it?
10%.
Huh?
Around 10 or 1.
The 10% is the density. But how much we add? We're going to add 10%. Right? But how much we're going to add to it? Do we know that, or is it unknown? It's unknown, right? So with the unknown, what are we going to do with that? Put a letter to it, right? Right? So let's say we add X liter of solution. Right? Now, then we get to steps 3. Now we're going to look at this. In this case, how much is our silver iodide. By adding we have combined the 4-liter solution plus 4 liters of 4% plus X liters of 10%. How much iodide put on this? All together. Now, we mixed. Huh? On here, step 2, what is silver? Iodide. 10% times what? 10% times what? X, right? Which is what? Is our 0.1x, right? So, step 1, step 2. Now on to step 3. What's the total silver iodide now?
6 over 10 is equal to 0.1.
What's that?
I'm probably wrong.
No.
Okay.
We add the silver iodide from the 4 liter plus silver iodide from the X liter. What's the total? Because we'll mix them together now. Put the two solutions together.
0.16 plus 0.1x.
0.6 plus. Right? We good?
Equal to 6.
What is our solution now? Remember, we mix them together.
6 over 100.
What's our solution?
4 plus x?
We had 4 liters. We have X liters add to it, right? So it is 4 plus X. Right?
What?
We got 4 liters. We mix with X liters.
Yeah.
That's how much solution we have after the mixing. Good? Question?
You kind of lost me in the second step.
Second step?
Yeah.
Second step, we said we're going to add X liters solutions, right?
Yeah.
We don't know what X is. This is unknown. We should figure out. So if this is the case, we know that X liter solution has 10%
Right.
density. So therefore, our silver iodide will be 10% times X. Right?
I think it's I understand what you're saying, but I don't, it's the algebra that I'm lost.
Okay, that's fine. We step by step. First step. We got silver iodide. We got 4%, right?
Yeah.
And we have 4 liters of those solutions. Right?
Mm-hmm.
So if we have 4 liter solution, therefore, because of 4%, our silver iodide will be 4% times 4, right? That's 0.16 liter.
Yeah.
Start with 4 liters. So you have 4 liter of solution, then silver has to be 0.16 liters. So if you divide this by 4, you got 4%.
Yeah.
Right? Now the second step is we're going to add some amount of the 10% solution.
It's the equivalency statement. What would the equivalency statement be?
Yeah, we'll get it here. Here will be equation we're going to set.
The one for the second step. Though.
Okay, second step, X liter solution is 10%, right? Right? 10%. So therefore, we know we have X liter solution, but we know our silver iodide will be 10% times X. This will be
That's where you lost
0.1x.
me, so.
What if we have X liter solution? What is our silver iodide?
It's a volume.
Right? Just like here, if we got 4%, is 4% times how many liters? Right?
If you're writing it as like this over this equals this over this, what would you write it as?
For this one, will be 0.1x over x. Let's give our conclusion. Right?
So, make 0.16 over. Because we did 0.16.
Okay. It's good. It's good. Let's just work through it.
Oh, okay, so the other one is silver iodide solution equals x over. Except we have too much silver iodide. Oh, no, this is the other solution. We have two solutions? Yes, one is 4% silver iodide, the other is 10%.
Yeah, we'll mix those two together. One is 4%, one is 10%. Okay, good. Good. Yeah, that's how we got understand. Okay, we good now?
Oh, look at that.
Okay, good? Good?
All right.
So, yeah, ask questions, okay, as they go through it, because that really help you to learn the whole. Yeah, if you don't ask us, then later on you get more confused, okay? That's how things build up. So, now after the mixing, we have this percentage, we have this density, right? But we know that after the mixing, we have this many, or this much silver iodide. Is 0.16 liter plus 0.1 times x liter. We still don't know x yet, but we're going to work it out, okay? Here is, basically here and here we just write the sentence in terms of math, okay? In terms of algebra. And now the third step is going to set up the equation, because without equation we cannot solve it. We have to have equation, right? So we good here. After the mixing, this is how many liters of silver iodide. This is how many liters of the solution. We good on this one?
Well, can you solve it out?
Now we're going to set the equation. What is our equation? What is our equation? Remember, this is n without 6%. So therefore, 0.16 plus 0.1x. That's silver iodide over total amount of solution 4 plus x. That equals to what's x to? Huh? 6 over 100, 6%. Good answer? Okay, so we can rewrite this as 0.06, doesn't matter. Just different way express it. We're good on here. Right? So now we're going to set up the the linear equation. So here is the equation in terms of percentage. It's a ratio. So in order to set up the linear equation, what we're going to do is going to times 4 plus x on both sides. Right? So why can I do that? Why can I do that? I can multiply 4 plus x on both sides of the equation. Why? What's the property there?
Multiplication.
Huh? It's because the equation then, the equation will be true if we multiply the same thing on both sides, right? So we still follow the basic math rules here, right? So what we got here now is become 0.16 plus 0.1x equal to, this here cancel. We did 4 plus x on this side, then we did
Wait, why is it 4 plus x instead of 4 plus 10? Oh, because 4 liters.
Right? Right? So this and this cancel, so we have this. So this all based on the property of the equation, what it means by the property of the equation, and also how we do in terms of numbers. These two we can cancel. We don't know what x is yet, but we just know that this has same amount of it, so we can cancel, right? Right? Think about that. When we're dealing with algebra, we are not necessarily dealing with any particular value. We are more concerned about the properties. So that's a property. Any two numbers, the ratio between any two same numbers is always 1, right? That's property we are using here. We got this side. How about this side? 0.24 plus 0.06x, right? Right? So what is the property we are using? Distributed property, right? Okay. So we're good here, right? Good. Now what we have here? Solving it. So what are we going to do? In order to solve linear equation, we what? We put the x on one side, all the numbers on the right-hand side, right? So what is going to the minus 0.06x on both sides? So we end up with 0.1x minus 0.06x. The reason I can do it is because the property equation, when you add or subtract the same amount on the equation is still true, right? It's kind of like balance. If you take same amount out or add same amount, balance it's still balanced. On this side, we can move this number to that side, minus basically 0.16. Okay. All right, we're good here? Yes?
Yeah.
So now this part becomes easy once we set it up. So this will give us what? 0.1 minus 0.06 is?
Oh, wow. It's 0.4. 0.04, sorry.
There, point
0.4.
0.4. This side? 0.08. So therefore x is equal to? Equal to what? 2 liters. Yes, we can plug back in and verify it, right? We can plug in back here to verify it. We should get 0.06. Okay, that's how you find it. Okay. So any mixture problem is like that. All you need to care about is like what that means by the density, right? Then you set up the equation for it. Once you set up the equation, then you solve it. You think this is a lot? This is not a lot. This is not a lot. This is actually easy, okay? Relatively speaking, okay, consider other things. Okay, we're good on this one? Alright. So, when do we finish today?
39.
Huh?
39.
39. So we got about 20 minutes. Good. Okay. So now we're going to move on to quadratic function. Okay. So I'm going to show you how do we derive the formula. Remember, quadratic equation, we have what kind of formula? Famous
Square.
formula for quadratic equation.
Negative b plus or minus square root of b squared.
That's one. But in terms of graphing, you need to what?
X squared plus bx plus c.
When we have, this is, okay, when you graph it, this is a quadratic function when you graph it. And notice what we have here. This one.
Origin.
This is called what?
Vertex. Low point. Minimum.
This point.
Vertex.
Vertex. And we have a vertex what?
Sorry, what?
What's the formula here? We got a vertex formula.
Oh, sorry, no, that's.
Right? Remember that? We have vertex formula. We should be able to figure out, given this function, given this function, what is our vertex formula? How do I find our vertex?
Axis of symmetry.
Okay? So most of the people forget, doesn't matter. I'll show you how to get there. Once you know how to get there, then it'll be much better. So you don't have to really memorize it. Okay. Vertex formula, we also have the formula for find the zero. Right? That's what Janine was talking about. To find the zero of the or the solution of the zeros of the quadratic function or the roots of quadratic function. Okay, so this graph is, there's a name for this graph. What's that?
What is the vertex formula?
What's the name for this graph?
Oh, parabola.
Parabola. Okay, parabola. The reason we call this have a name here, actually, the Greeks find something very interesting. It's amazing they can do this 1,000-2,000 years ago. They find something very interesting. They said, if I got a parabola, first of all, there is symmetry to it, right? There's symmetry to it. So if I have I have something go like this. Just went through the vertex.
Right through it. Right through it. Trying it stuck in the ground.
Okay. Then this side and that side are mirror image. Right? So this one's called
Axis of symmetry.
axis of symmetry.
What is the vertex formula? Oh, you're going to prove it.
Okay, all right. So, what the Greeks find, Greeks doesn't have this. They don't have the Cartesian coordinates system. It's much later. More than like 1,500 years later, have this system. But what they found is, for those kind of graphs, like for the Greeks, they more consider how do I graph it, because they are doing geometry. They're always trying to figure out how do I graph certain things. Okay, so they figure out for this kind of things, they always have a special point right there, and they give a name called the focus. Okay, and they say that if from here to here, if the distance is d, then same distance away from this point, same distance, this point, if they put a vertical line to it, they found that any points on the graph, the distance between here to the focus is the same distance from here to here. Everywhere. If here's someone here, this distance is the same as this distance to here. Yep. You see here, if this point here, definitely from here to here is same from here to here, right? Okay. Anywhere on this line, they said that the distance between here to the focus is always the same. This and this are equal to that. This are equal to this. This are equal to that. So even though the graph doesn't show, because I didn't graph it by scale, but that's what we find. And that's how they can graph it. Okay? Find the line here, they check the distance, and they figure out, okay, like this. Alright, okay? So that's what they found. So the distance between any points to the focus is the same from the same point to this line here. And this line has a name to it. Directrix. Okay. Alright? So now we're going to see how do we come up with the function. Now we know the graph. We have to know the function. Okay? For the Greeks, they are done. They don't care about function. Functions just functions, that concept came much later. But to us, we want to see how do we do this. So the best way, the way to start with is that we're going to put that into the Cartesian plane, right? Without Cartesian plane, we cannot do anything. We cannot do calculus. Put in the plane, and we put this as our x-axis. And put this, the axis symmetry, put as a y-axis. Okay, so now we want to find the distance between here and here and here, right? And this would be our what? X and y. Any points on the graph, right? So what we're going to do is, now we're going to set the equation. So what is our equation here? We know this and this have the same length, right? What's the length between here and here? So first of all, what's this point? How do we write this coordinate for this point? The focus. Focus is what? 0d, right? Now the distance from here to here is,
X. Oh, sorry. 0.
we learned that, right?
0x.
The distance formula.
I lied.
What's that?
I give up.
Square root of x2 minus
Square root of x minus what?
0.
X minus 0, right? That'd be x, right?
squared plus
Right. Then y minus d, right? Y minus d. Okay. This one you should know that by heart, okay? You can see that this is based on the famous Pythagorean theorem, right? The distance formula. We go down this one. Any question here?
How did I'm confused how we got there?
Mm-hmm. What is from this point to this point?
Oh.
What's the distance formula? Is x coordinate difference between the x coordinate, x minus 0 is x squared plus this minus d squared.
Why?
Because
Yeah.
this is what? Hypotenuse, right?
Exit. Where did you get minus d?
Y, this is d here.
Yeah.
This length
Yes.
is y minus d.
Yeah.
So the square of this
Yeah.
plus square of that,
Yep.
add together, take square root. That's our length of hypotenuse. Perfect, right? So this is what? How about from this to here?
y.
That should be easy, right?
Y plus d.
Y minus d, right? This part of minus d, right? Or you can think this is a d, this is a y, so y plus d. Right? You good here so far? And we know this has to equal that, because that's the property the Greeks found. Everywhere on the graph, this had to be true. So this is equal to that. Good so far?
Wait, the distance of that.
From here to here is the same from here to here.
Okay, yeah.
And now we can square on both sides, right? That's also the property of equation. If you square on both sides, the equation is still true, right? But not vice versa. Okay. So we square on both sides what we have. This side is x squared plus y minus d squared equal to y plus d squared. So far, so good? Now, x squared, what is this? What's this? You should know this by heart, okay? Same thing.
Y squared plus b squared.
Y squared plus minus here. Minus what? Huh? A and B, think about that. What's that? 2 D
Y.
Y. Right?
Because we have to FOIL it.
And plus D squared. How about this side? This will be easy now.
Y squared plus 2.
Y squared plus 2dy plus D squared, right? Now, D squared and D squared is the other thing. We can get rid of them. X squared and X squared are the same. We can get rid of them. So what's left is x squared minus 2dy equals 2dy, right? When we add 2dy on both sides, so we end up with this. 2dy plus 2dy equals 4dy, right? Therefore, y equals to 1 over 4d x squared. Okay. Now let's find the function for the graph. based on this graph, based on the property of this graph, we find this function. Right? That's our quadratic function, right? The simplest one. Right? Because here. So, but we're going to know what happens if we are not exactly at origin. We have something here away from it. And this point is our vertex point, and we write as h and k, right? Remember that vertex formula? Use h and k. Okay. So how do we do this? Same thing, right? We use the same idea because we know that it has to have a axis symmetry, right? At what? What is this line? Huh? X equal to? X equal to what? H. That's the line, right? And we know that it's going to have a focus right here. And let's say this is distance is d. Same thing as before. Then same distance away going to be our directrix. Right? And this line is what? Y equal to this line. Here's k. D below that. Huh?
K minus D?
K minus D. Right? You good on this one? Right? Because our k is from here to here. Our d is from here to here. Right? So then this distance has to be k minus d. Right? Okay. So we have that set up. Same thing, we're going to use the distance. We've got here from that and from here to this line. Okay? And this point is our x and y. Now, in this case, what's our focus? What's our focus here? XY coordinates for our focus.
H.
Focus, the x-axis is h, right? How about y? We got k here. From here to here is k. Then there's d there. Right? So we now know this point. We know this point. Okay? Same thing, we're going to find the distance of this line, which should be equal from this one to here. So on this side is what? Square root of this is xy, this is h k plus d. X minus h, perfect, square plus y minus
K plus D?
minus k minus d, right?
Minus?
Wait, why K minus D?
Because y minus k plus d.
Oh.
We just put in there, right? Square. Good? How about from here to here? Hmm? From here to here. Y minus k minus d, right? Right? Y minus, because this point is k minus d, right? Remember, this is a line there. So y minus k minus d, which is y minus k plus d, right? All right. Just give me 1 minute. We'll get there. Okay. Before we're solving it, we're trying to use a common trick when we do mathematics, make things much easier. So what we're going to do is we're going to change the symbols. So instead of x minus h, I put that as alpha. And that's defined as x minus h. And use a beta. That is defined. We can put this in defined as y minus k. Right? Okay, so if we do that, what we got ends up with is this. Alpha squared plus beta minus d squared equal to beta plus d, right? So we open on both sides, alpha squared plus beta minus d squared equals beta minus d squared plus d squared. Okay, does that look familiar? Does that look familiar? This is what we did early on. Right here. Right? This is the same. This is the same, except we use different symbols, right? And we end up with what? This. Right? You good? So therefore, what we got here? The beta would be equal to 1 over 4d alpha, right? Right? Because it's the same, right? This part tells us the same relationship as this part, right? We good on this one? So now we're going to go back. That makes time much easier to find any points. Okay. So we know beta is what? Beta is y minus k, right? Alpha is x minus h. So therefore, the square. So therefore we have y equals to 4d x minus h squared plus k. Okay. So tomorrow we'll continue. Make sure this will be on the Google Classroom. Make sure you understand what's going on today. Okay. Very, very important for you to understand every step. Okay. Otherwise, you won't be able to. You won't be able to understand calculus.